So good afternoon. So before starting this live interaction session, we will wait 2 to 3 minutes. Let others join. Let's see whether others are joining or not. Okay, so we'll start today's session. So first of all, I welcome all of you to this live interacting session. So this is our first live session on this topic, which is on this subject, which is the conduction and convection heat transfer. So this course will consist of the basics about this heat transfer phenomena like this conduction and convection. So the course instructor is Professor Chakrabarti and Professor Shum from IIT Kharagpur. I hope that you have gone through their courses. So I am here as your TA from IIT Bhubaneswar, and I will be dealing with some numerical problem and some fundamental concept that you have already studied. And my main motto is to give you an elaborate explanation about this concept. And I hope that this concept will help you to solve this numerical. Okay, so before this, we will let me introduce this course to you. So first, I am Niloy. I am from IIT Bhubaneswar. So I am doing my PhD in IIT Bhubaneswar in the field of thermal science. Basically, I am working in boiling heat transfer, which is one of the efficient method of heat transfer. So the this conduction, convection, and radiation. As you know that radiation is one of the highest mode of heat transfer. So after this boiling is another important phenomena. But this boiling and radiation is not in your course curriculum, so we will not be dealing with this. So what we will do is that we will basically study this conduction and convection. So why this course is important? So basically this course will provide you with a fundamental concept which is required in most of the engineering field and even in the biological system, even in our body temperature. As you have seen that our body temperature rises during fever, and all this phenomena is because of this fundamental concept of heat transfer. So once we will get to know this fundamental concept of conduction and convection, which is quite essential to learn this governing equation responsible for the heat transfer based. And as you once got to know about this concept, you will be able to solve some real life problem. You will able to solve the governing equation, and after that you can go into high studies, if someone is interested in high study, he can write their code on its own and can solve this governing equation based on this conduction convection. And though radiation you will find, but as I have already told that radiation is not in our curriculum, so we will be dealing with only this. Okay, so this course is basically of 12 weeks, and if someone is interested in giving this NPTEL certification exam, so you have to enroll within this 26th January. I hope that if you are interested in sitting this exam, that will definitely help, because you will get the basic concept, and with this you will compete with the student across the country, so that will definitely help. So see, in already as you have gone through these courses, so you have got some basic fundamental, right? So before starting these courses, you should have to at least one time you should just go through this thermodynamics and fluid. This concept will definitely help you to understand this subject in a better way. Okay. So I will do is that basically in the first week, what you have studied is that you have studied about this conduction and about this steady state 1D conduction equation, and also you have learned about this convection and how it differs from conduction, and the internal energy form of this conduction equation and how it can be represented in the CP form. All this all these thing has been taught by Professor Chakraborty and Professor Shom. So I am here to help you with some numerical problem which will help you in solving this assignment already provided from this NPTEL site, right? So before starting with this numerical problem, I will help you in recapping the concept which has already been discussed. Okay. So, so first, so the first is what is heat. You need to know what is heat, right? So heat basically is not something a body contain. Okay. So it is the energy in motion due to temperature difference. So if someone have to explain the heat, you can say heat is the energy in motion due to the temperature difference. Say there are two bodies. So these are the two bodies connected with each other. Okay, this is body 1, this is body 2. Say this body 1 having 30 degrees centigrade temperature and body 2 having 30 degrees centigrade. So that means there is no temperature difference between these two body. So that means there is no heat flow. No heat flow. So for heat flow, there should be temperature difference. Okay, so this is not only the law of heat and mass transfer, so this is the law of nature. Even the nature work on the same concept. So say if a body is at 50 degrees centigrade, just a minute, and another body is at 30 degree centigrade. So just tell me how the heat will be transferred, whether it will be transferred from this hotter body to the colder body or colder body to this hotter one. So basically the always it flows from the hot to cold region. So that is the direction of heat flow. So that is from hot to cold fluid. Okay. So that is the concept here. So now why the heat flows? The first concept is why the heat flows. So basically the heat flows because say this is a solid block. So if you observe this solid block under the microscope, you will find atoms and molecule. Okay. What you will find? You will find atoms and molecules. So these atoms and molecule always vibrate. So for a solid, this vibration is comparatively less, whereas for liquid and gaseous, it is comparatively more. This vibration is more, or the movement is more. So say if this body, if we are two bodies are there, this is a hot body and this is a cold body. Okay. So if you are applying, so hot body means there is a temperature rise. So because of this, the particle inside this body will vibrate more. Whereas in the colder body, this particle will vibrate less. Okay. So if a particle is vibrating faster or vibrating more, that means it will collide with the other bodies, right? So if I connect these two body, a hotter body with a colder one, say example, if I talk about a cup of tea, so this is a cup of tea. If I pour it into a water vessel, what it will do? Because it is a hot tea and this is cold water. So what will happen? The heat will transfer in this direction, right, to the colder water. So what basically happens here is that this hot body or the hot tea in the particle inside this hot, here there is more vibration, right? And the cold water there is less vibration. So what will happen? The particle from this hot body, because of its vibration, will move either and other, and because of this, the particle inside this cold body will disturb, and as a result there is collision among each other, and because of this the colder particle also start to vibrate comparatively more compared to the previous case, right? So if a particle is moving faster, that means it has a certain kinetic energy. So if it strike to with a body having lower velocity or less velocity, what will happen? After strike, it may get more kinetic energy, and the kinetic energy is directly proportional to temperature. So that means in return this temperature of the colder body will increase. So where this temperature will comes from? This comes from the kinetic energy it get from the faster moving particle from the hot side, and because of this colder body is getting this kinetic energy, and so the heat is transferred from the cold side to the hot side. So what happens? So the energy is getting transferred, and the temp, and this will continues until and unless the temperature is equal on both sides. So that is the fundamental concept of heat flow. So in both this concept, so in the heat flow, what I am discussing right now consists of both conduction and convection. However, I haven't segregated this till now. So let me distinguish this based on conduction and convection. Okay. Up to this, any confusion? Sritesh, up to this any confusion? So just a minute. Just a minute. There is some problem with the screen. It is not moving. Now I think the screen is visible, right? Yes, it is visible. So since the screen is not visible, right now I think the screen is visible, right? So I will be explaining this once again. So first, so I am recapping this concept. So I am recapping this thing. First is the heat. So what I have told that heat is basically the energy in motion due to temperature difference. So for heat there should be bodies, say two bodies or three bodies, and there should be temperature difference between the two bodies, say T1 and T2. If there is temperature difference between these two bodies, say T1 greater than T2, that means the first one is a hot body, next the T2 is a cold body. So the heat will flow from T1 to T2. So this is basically the fundamental concept of the heat. So and why the heat flows? Next question is why does heat flows? So basically in every particle, say this T1 and T2, if I talk about, say this is a body, this is an two same body, see it is an hot body. So in a hot body inside there are certain atoms or molecules, right? So as it is supplying heat, so what happens? This particle is getting excited and it started to vibrate. that means it will started to collide with each other, and then because of this the vibration is more, right? And in a colder body this particle do not vibrate that much. That means in a cold body the vibration is less. Okay, this is a cold body. So if you connect these two body, say this is a rod. If I am talking about a rod, this is the rod. So this portion you are supplying heat, hot, and this is cold side. Okay. So what will happen? This particle here, there are certain particle, and this particle in the cold side there are particle, but this particle do not vibrate that faster. But on the hot side, because of the heat, the particle is taking certain kinetic energy, and it will started to collide with each other, and because of this once a particle is collide with another particle, it will transfer some of its kinetic energy to the next particle, right? So that means it is transferring the heat from first particle, say this is the first particle and this is the second particle, it is transfer some part of its kinetic energy to the second one, and after that this second particle strike with another particle, say this is the third particle, again some kinetic energy is transfer. So similar to the fourth particle, and and similarly as it comes to the fifth particle, what will happen, it will transfer some kinetic energy. So the kinetic energy is equivalent to temperature, so that means the temperature of this side will definitely increase, and as it is taking some kinetic energy from the previous molecule, so it will again move faster, and a vibration will start in this region, and because of this the colder side will get the heat. So this is the mechanism in which the heat flows from the hotter side to this colder side. That means these fast vibrating molecules collide with the small ones, slow ones, and the energy is getting transferred. And how long it will continue? It will continue unless and until the temperature on both sides remains equal, or throughout the domain it remains equal. It will continue unless temperature equalizes. Okay, so this is the concept of the heat, and in this and based on this heat we have three mode of heat transfer. Basically this is conduction, convection and radiation. So conduction is basically because of the temperature difference, and convection is basically because of flow, whereas if we talk about this radiation, it is because of the motion or because of the heat transfer through electromagnetic wave, and it does not require any medium. Okay, so that is the fundamental concept, but in this course curriculum we will be only dealing with conduction and convection. So next we are coming to this concept of this conduction. Okay, so what basically is conduction? So after the heat we are coming into this mode of heat transfer. It is a primary mode of heat transfer, remember. So if you Google the types of the heat transfer, so you will find there are three primary mode of heat transfer. This is conduction, convection and radiation. But as you have gone through these courses, and at the end of the courses you will get to know that basically there are two primary mode of heat transfer. This is conduction and radiation, but the convection is not a primary mode of heat transfer. But in your preliminary level, we will consider the conduction, convection and radiation all are the primary mode of heat transfer. And why I am saying this thing, I will elaborate in the upcoming slide. So this is a primary mode of heat transfer. So in conduction, what happens? The transfer of heat through any material, metal, it may be anything, without any bulk motion of the material. So that means if there is no bulk motion for this types of heat transfer, it doesn't require any bulk motion of the material. Okay, so it is basically because of temperature difference, right? So say if two bodies, say this is a body at 30 degree and this is at 30 degree. So either heat transfer will happen? No, because there is no such temperature difference. So and how will the heat transfer? Because if there is no temperature difference, so that means in both the side of the body, the molecule having the same types of kinetic energy, and because of this, there is stability in the body. So why will it transfer it? If there is no instability inside a body, so why will it generate this? It will transfer the heat from one side to another. Because of this, there should be always temperature difference in case of conduction. Okay, so that's why the previous concept that I have taught in the previous slide. So in this rod, the concept of this rod, what I have discussed in the previous one is the concept of conduction basically. So basically here this energy move from hot end to cold end, from hot side to, say you are giving heat here. So the heat is transferred from hot side to cold end. Okay, okay. And the fundamental concept is the molecular vibration I have talked about. And also, if there is a metal, molecular vibration is there in all material, whether it is a metal, it is a plastic, anything. There is molecule, right? If you observe in the microscope, you will observe this thing. But in the metal, there is also free electron. So that thing you have studied in chemistry, right? So because of this free electron, a metal generally conduct electricity, and also because of this metal, the conduction is comparatively more in metal. Okay, so this is the basic concept. So if someone asked you why conduction happen, so you just say that conduction is happen because a temperature gradient exists. What you will study, that is temperature gradient. What exactly is temperature gradient? So temperature gradients means, if this talking about this rod, say this is the, if the total length is L, say up to this I consider it as small x, so this is the initial scaling start, so it is 0, and this point is your x. Okay, so in this point, say the temperature is T1 and here the temperature is T2 at this point. So the temperature gradient means a change in temperature at a distance x. So that means at the distance x, the temperature is T2. What is the change in temperature between these 2 points? T2 minus T1. And what is the change in the length? This is x minus 0. Okay, so this change in the temperature by change in the length, this is known as temperature gradient. So in derivative term, we can write it as dt by dx, dt dx. So dt is the change in temperature with respect to change in coordinate or change in space. Okay, so this is the concept. So any confusion up to this? If there is no confusion, can I move to the next concept? Okay, I am moving to the next concept. So next is the Fourier's law of conduction. So after this concept, we will move to some numerical question. So that will help you to understand this concept and also help you in carrying out your assignment. Okay. So just I am recapping this Fourier concept. What you have learned that I am talking about 1D Fourier's conduction equation. So this is k del t by del t del x. So what this is? This is your heat flux, right? And this is temperature gradient, and this is your thermal. This proportionally constant is known as thermal conductivity. So this is in terms of heat flux. What basically is heat flux? So this heat flux basically is the heat supplied by area. So you may get confused with the main forms of this equation. Somewhere you will find this thing, and some people confuse this small qx as heat, but this is basically heat flux. So in terms of heat transfer, not heat flux, so you can write it as minus k ax. So this is for only heat transfer in x direction, right? For y direction there is certain values. So why this negative term is there? So this negative term indicate that this heat is transferring in the direction this opposite to this is a negative temperature gradient. Say in this rod initially it is 30 degree and this is 25 degree. Okay, so this distance is say your 5 m. So del t by del x, if you are writing, that is 25 minus 30, right? And this in is 5 minus 0. So you will get a negative value, right? So to counter this negative value, that's why there is a negative sign. So that it indicates that the heat is flowing from high temperature to low temperature. Okay. So to counter this effect of this negative value, so there is a negative sign. And its important is that it shows that the heat flows from high temperature to low temperature. Okay, this is for 1D format. And say if I write it as T1, T2, and this as L. So this equation can be written as minus K A, area let us assume it as A, and it should be T2 minus T1 by L minus 0. So minus, if I consider, that is Ka T1 minus T2 by L. So that means see, T1 is high temperature, T2 is low temperature. That means heat is transferring from higher to lower. So we'll get this concept. Okay. So from this equation, what I say, that Q is proportional to area, Q is proportional to thermal conductivity and also to the temperature gradient. So if what happens, when will the value of Q will be high? If the value of K is high, or if A is high, or if the temperature gradient is high. Say if someone say for two bodies, say one is a thicker wall and another is thinner wall, having the same temperature difference, which body will give you high heat transfer? Because here you can observe that this Q is inversely proportional to this distance. That means if it is a thickness, so if the thickness is more, the heat transfer will be less. So that is the concept. That's why see we are using some insulator over a, this is a metallic pen. So in our household you will find these types of pen where there is a, so where there is a handle like this handle is covered with an insulating material. So inside it, though there is a metal, but there is a thick layer of material above this metal. So because of this thick material, the heat is not able to transfer. See, because see, if the value of L is more, that means the thickness is more, what will happen? This value will be less, so the heat transfer will be less. So, is considering this assumption, insulation is done. So, this is the fundamental concept of insulation. Okay. So, in generalized, we can write it as minus K del T. So this is a shortcut form, so it is a gradient term. What is del T? Del basically indicate I cap plus. So this is basically in your vector term. And temperature, say temperature we know is a function of x, y and z, and sometime for steady state, this is for steady state. But for non-steady state there is a profile T. That means say a body is there in this liquid. See, in this vessel, you are supplying heat from the bottom, right? So the first this liquid will get heat up, and after this it will transfer heat to the upward liquid, and as because of this convection is there, right? So what you will find, the based on this concept, you will see that certain changes will observed at the bottom or at the top. But if it is in a steady state, what you will observe that if at 6 p.m. if the temperature at the bottom of the surface is say 100 degree, and here it is at 90 degree, 100, say it is at 110 degree, and the top is at 100 degree at 6 p.m. So if you come around 6:10 p.m., so it will remain same, that is bottom is at 110 and it will be at 100 degree. So with time there is no change in the temperature profile across the space. So that is the fundamental concept. Okay, I hope you understand this concept. Any confusion up to this, please raise your concern in the chat box, or you can on your mic and ask the question. Previous concept, yes, definitely. So the concept what I am talking about is this Fourier's law of conduction. Okay. Say a temperature. I am talking about temperature. So temperature basically is a function of x, y, z and t. So most of you are not aware of this concept. What is x, y, z and t? Say this is x, your x axis, this is your y axis. So this is the 3D coordinate, right? So if I consider a box, wooden metallic box, so this is your metallic box. So this metallic box, in the metallic box there is certain x direction, certain y direction, certain z direction. So if you heat it up, say from the bottom, I am applying heat from the bottom. So what will happen? There will be change in temperature, right? So this change in temperature is in the x direction. There is certain change in temperature. There is certain change in temperature in the y direction. There is certain change in temperature in the z direction, right? So this change in temperature and also with time. So sometimes it happens that you are applying heat here at 6 p.m. you are applying heat. So I am considering a certain point. This is a point in the space. So at this point, if the temperature is initially say 50 degree, right now at 6 p.m. it is at 50 degree. What will happen at 6:10? As you are supplying heat, continuously supplying heat, what may happen that at 6:10 it may be 60 degree, right? So what happens is that this temperature is changing with time. So that is not a steady state. That is a normal scenario. Okay. So but say this solid block after heating for 1 hour, say at 7 p.m. it gets the whole surface is getting heated up, uniformly getting heated up. So this point is having now the temperature of this point is say 100 degree. At 6 p.m. it is at 100 degree. So after at 7:10 if you see that this temperature will not change. Why it will not change? Because this solid body has already get the desired heat it requires. The body cannot take more amount of heat. So that's why after 7 p.m. there is no change in temperature is observed. That means with change in time we will not see any change in temperature. So that concept is known as the steady state. This is your steady state. Okay. So up to this steady state, is it clear? Please on your mic and tell. Okay. So now you said that this concept T is constant. So I am considering T is constant. So if T is constant, so now the temperature depends on how many parameter? Just tell X, Y and Z, right? X, Y, Z means a position of the block. That is mean this position, it may be any position. So what we are studying now, we are studying at the temperature when T is constant. That means there is no change in the property with time. Okay. So this Fourier law you have studied heat flux in one direction you have studied, that is minus K into this is the Fourier law that you have studied. So this is in x direction, that means in this direction, in the topward direction, the heat flux is minus k del T by del x. Okay, so the negative sign indicates that the heat is transferred from the high temperature to the low temperature. Okay, because say this point, so I am taking 2 points. This is your point 1 and this is your point 2. Carefully observe these 2 points at point 1 and point 2. So if you are supplying heat, so initially the temperature of point 1 will be more than that of point 2. Say at 1 the temperature is 60 degree, at 2 the temperature is 55 degree, right? So in the above, if del T by del X you take, what is the temperature difference? So from 1 to 2, if you observe, the temperature difference is 55 minus 60, because 55 is your 2 point is your final point and 1 is your initial point, and the distance, say the distance is your 5, so I consider it as 5. So what you will get, minus 5 by 5. So there is a negative coming here. So del T del X is basically negative. So to make it positive, there is a negative sign before. That means the heat is transferred from the hot to the cold side, and the negative is to compromise with this variation or with this negative temperature. This one is known as negative temperature gradient. Gradient means change in temperature with distance or change in temperature with length. Up to this it is clear? Please tell. No, no, one is the temperature of point 1 is more, not less. You see this one, this is 60 degree and this is 55. Huh. So why the temperature of point 1 is more? So if I talk about this thing, say this is a rod. Okay. So this is the point 1, this is point 2. At point 1, so if you are supplying heat from here, right? At below, from the below you are supplying heat. So what will happen, the certain particles are there, because of this heat this particle get excited and it will start to vibrate randomly, and because of this vibration this particle gets struck with another particle. So and because of this, the kinetic energy from from one position is transferring to the next particle, and like that way it is transferring to this next. In the same way it will continue unless and until it reaches the point 2. So what will happen, the kinetic energy, say the kinetic energy of this point is kinetic energy, say this is 100. Okay, after striking it is giving 20% of its kinetic energy to this particle. So overall its kinetic energy will increase, right? Is it clear? Huh. So because of the heat, say anywhere you are supplying heat, the particle at this position become random and it will started to move and vibration started at this point. So the all the particle will strike with each other, and you know that if a particle is strike, and say in your real life, consider, you just observe, say some people are sitting in a room quietly, and a fellow comes from behind and just strike a fellow with his hand or with a rod, then what will happen, there is a there is a fight between these people, right? So that is the same phenomena that is happening here. So if you are supplying heat, there is a confusion or there is randomness in the particle, and this particle will what will that they will continuously strike each and other, and because of this whole rod na, so from this heated surface to this cold side, all this particle is getting excited. They are in a mood that we will have to participate in this fight, like this. So all these particle in this heat transfer will want to take this kinetic energy from each other. So until and unless this phenomena continues, unless the kinetic energy of all the particle remains same, is about same, say this phenomena will stop once the kinetic energy of all this particle will goes to 50, say, for assumption. So and after this what will happen, if the temperature at T1 and temperature at T2 both will be equal, and then the heat transfer will be uniform. So unless and until these two temperatures are equal, the conduction will carry on. Okay. So can I move to the next one? What? What? Just a minute. Yes, yes, definitely decrease. That's why say it's a good question. That's why I say if you are supplying heat, if you are not supplying, say initially, if you supply heat and after that you stop supplying heat, then what will happen? Initially, the rod at this point, this temperature is 100 and this is 50 degree. Okay, and you stop supplying heat. So after a few moments, what will happen? The temperature of the rod at both point should be 75 degree. This around say 75 degree. This is because you are not supplying heat at this point. So at this point, this temperature will decrease. So in this scenario, the kinetic energy will decrease. But you are continuously, if you are continuously supplying heat, that means though this particle is transferring some of its kinetic energy to the next particle, but after that, because of this heat, this particle again take up this kinetic energy. So this though it gives up 20% of this kinetic energy to the second particle, this 20 particle is getting compensated by the heat. So again the kinetic energy goes to 100. So the kinetic energy will not reduce if you are continuously supplying heat, but the kinetic energy will reduce if you are not supplying heat. Now it is clear? Yes, Max. So what you said, just repeat. Yes, yes. So just a minute. I am giving you. This is getting clumsy, so that's why maybe I think it is all right. Say, I am giving you a good example. I think now it will be clear. Say, I am giving heat. So, kinetic energy, I am taking three particle for your assumption. Okay, this is one, this is two, this is three. Say the kinetic energy, initially the kinetic energy of this particle is 100. This kinetic energy of this particle is say 60, and kinetic energy of this particle say 30. Okay, not degree, 30. So what will happen, as you are supplying heat, so it will transfer some of its kinetic energy. That means, say from its 20 kinetic minus 20, so this 20 is getting transferred to here. Okay. So and after that, once it strike with this one, say it will supply another 15 to it. So as it is supplying 15, so from here also minus 15, right? So from there you can see that the kinetic energy is getting, the total value is around 80. Okay, but as the heat is continuously getting supplied, heat is supplying means the temperature will increase. So we know that this kinetic energy is proportional to temperature. As the temperature will increase, this because of this rise in temperature, the kinetic energy of this particle is automatically get the energy it loses. So this plus 20 is because of this heat. Okay, so that's why this kinetic energy will continue, will always be 100, though it is giving energy, but at the same time it is also taking the energy to 100. So this phenomena will continue unless and until every particle in this body having the kinetic energy 100. Okay, that is for the cases of heat supplying heat at an end. Is it clear now? Okay, so I am moving to the numerical section. Next thing, another thing is that if we are not supplying heat, then this kinetic energy will decrease unless and until the kinetic energy of the all particle remains same. It may be 75, it may be 60, but as you are supplying heat, so see, supplying heat is basically you can relate it with your daily life. So you are eating food, right? So you can eat certain amount of food daily, so you got energy, so that is fixed energy, right? Say your energy level is 1000 kilocalorie. So after you have gone to play cricket, and after playing cricket you loses 300 calorie energy, so that means 700 calorie is remaining in you. So if you again take food, then this calorie is getting converted into 1000 again, right? So that is the thing, the heat is doing the work that the food is done for us. So now is it, I hope it is clear. Okay, so I am moving to some numerical question. So based on this fundamental, okay, just a minute. So just this based on the concept what I have discussed till now, so try to answer this question. So better you attempt this answer in the chat box, or you can use your mic also, not an issue. So the question is, this conduction mode of heat transfer take place in all, first option is in all the material medium due to temperature gradient, only in a stationary medium. Both next is both A and B are correct. So you are saying B. And one more fellow there. Here. Sritesh, your answer. Okay, so Arya. So Arya, you are from which state? Huh? Huh? What? Uh, in the insulator. Ah, okay. I am explaining this concept. just so basically in insulator the heat transfer is quite negligible, and why it is so, I am just explaining you this concept. So though heat transfer is there, so in insulator this particle, so certain particles are there in an insulator, that particle are closely packed. Okay, so that particle are very much closely packed, and these molecules are like that. If there is, you are supplying certain, these particles have a certain enclosure around it, that if it somehow takes some energy, it is not able to transfer to the next particle. So that is the phenomena of its molecule. Or say in case of electricity, if you are talking about, so why insulator do not able to transfer this electricity? This is because the free electrons are there, right? These free electrons are not able to, in the metal the free electrons are there, so this free electron participate in the electricity transfer. But in case of your plastic or any insulator, this availability of free electron is quite less, even negligible. So because of this free electron, not only the electricity, the energy, the heat is not able to transfer. So these molecule here are your stagnant molecule. They neither participate, they are like that. Our phenomena is just to keep bonding among each other. Whatever may be the external effect, we will not do any work. So that is the type of mentality these molecules have. Okay. So it is the free electron. So each and every material have certain free electron. Like the metals have some free electron which participate in these types of phenomena. You got it? Yes, it's happened very much slowly. So that's why even if you see the what is mm, in the induction, these types of handle is there. So if you see, though it is an insulator, you will feel a little amount of heat, right? Very little amount of heat. Have you seen this thing? This handle I'm talking about. So say in your, even any time in your household, if your parents is cooking something in just a vessel, so if it is in hot condition, so this insulator catch through this handle, which is an insulator, you will feel that a little amount of heat is there. So you can't able to distinguish this thing, because if you have to distinguish these things, you have to catch a thing that is at the room condition and this metallic rod. So you will able to understand the temperature difference, that though it is an insulator, certain amount of heat flows through it. A very little amount of heat flows through. Okay. So, the question is that this question I am talking about. So another concept, let me about this insulator also. So this is if I talk about the fundamental level. So in the fundamental level, two things are there. This is, I am talking about the lattice vibration, like the vibration that I have talked about in the previous slide. That is also known as lattice vibration. So if I talk about in the fundamental level, okay, and next is the, what I say, free electron. Open. Always remember So the question that you have asked is quite important for your NPTEL exam point of view, because certain asks is what is the phenomena of a material that help it to conduct. So the question can be asked. So you say that these are the two phenomena, that is a material having these two property. One is a lattice vibration or molecular vibration, you can also write. Next is the movement of the free electron. So this basically this movement of the free electron is in metal. Generally metal free electron movement is there, but in other materials like your insulator, this movement of free electron is very negligible. But this vibration or lattice vibration is there in each and every material. In insulator, this is also less. So these two phenomena you need to remember. And coming to this question, the conduction mode of heat transfer. So this conduction mode of heat transfer, it is taking place in all medium. That is also correct, right? Irrespective of liquid, solid, vapor, anything, the conduction is there. And also you said that the temperature gradient is there. This is also correct, because only and when the two body having certain temperature difference, then only it will be able to transfer heat. Because if the temperature difference is there, that means the vibrational that this molecular vibration is different in two body. So one body can participate with the other body, and because of this the heat transfer will happen. So only in stationary medium, which is not correct. In moving medium, heat can also transfer. Can you give me an example where a moving medium can transfer heat? Adia, just from your real life incident, can you give me an example where a moving medium can give moving me- uh, moving media can give this conduction phenomena? Moving medium. Moving medium. The medium means liquid, solid, yeah, liquid, like this types of. So I'm saying that molten material. Yes, molten material. Good. So in molten material also, the material is moving, but also its conduction is happening. Even so, you are in which year? BTech, BTech or MTech? BTech, which year? First year. So you are in which institute? Okay, great. So you are in the beginning of your BTech career, so you will learn many things in mechanical engineering. Like you will learn about this casting. You have heard this casting? Oh, you are in mechatronics. Okay. So I am talking about this casting. So you see the vessel in our home, like this can or this bowl. You have observed in your home for cooking purpose. There are certain vessel for making rice, chapatis. So all these material, if you observe, are made. Many of this material are made using this casting phenomena. So in this casting, the medium moves. So the what happens in this medium? This material, it was a molten material, na. So this molten material is poured inside a chamber, and after this, because of this conduction, these types of structure is making. Okay, so the correct option is option D, because both A and B are correct. So is it clear? Okay, so I am moving to the next one. So it is a simple and tricky question. Just understand your fundamental concept. So for a given amount of heat transfer during a steady state, see the what steady state is there, and one dimensional heat conduction. One dimensional means I have talked about x, y, and three dimension. So in this question they are saying that only in one direction the heat conduction is taking place. with constant thermal conductivity and no internal heat generation, lower the width of the wall, the temperature gradient within the wall will be what? So please try to use this Fourier's law and use this Fourier's law and try to answer this one. It would be universe. Yeah, yes, definitely. But what should be the answer? How it is higher or why? Uh, oh, huh, uh, yeah, you are partially right. Why I am saying this thing? Just let me show you this thing. So you are saying I am writing this formula. What are the Fourier's law? Just tell me the Fourier law. Just equation. Q. Huh? Okay, okay. You are talking about this in terms of heat transfer. Okay. So one day, so I write it as Qx. This is minus K. What is the significance of the minus sign? You know? Why? So I am telling. Just say again. I am taking this example of a rod. Okay. So this point, this is 100 degrees C, 80 degrees C, 60 degrees C, and this point is 40 degrees C. Okay. So this is the x value. Here x is 0, here x is 2, x is 4, x is 6. Mhm. So this is I am talking about the rod. So is up to this any I think no confusion. See. So what is given that the thermal conductivity is constant. That means K is constant. So K is constant means an area. Is there anything about given for a given amount of heat transfer during steady state through a with constant thermal conductivity, and area nothing is given about this area, so we consider area as also constant. So I can write what you have said, that this is proportional to this one, right? So that is the you say what you say, that as the temperature gradient lower the width of the wall, so if the value of x decreases, then the value of t will definitely be high. But the thing is that it is talking about the temperature gradient. Temperature gradient means this whole term. The question is not asking about this temperature. If it is asking about this temperature, then the answer will be different. But in the question, it is asking about this temperature gradient. That means change in temperature with length. So these 2 points, I am talking about this. Now I am showing this. So just observe this part, only this part. This is your 1 and this is your 2. So I write del t by del x. So Arya, please tell what is del t by del x here. 18, this is 80 na. So 80 minus 100, so and this is 2 minus 0, so what you will get, minus 20 by 2, which is minus 10, right? So now I am taking another reason. So so this is I am taking another color for your understanding. Say this color I am taking. I am taking up to this. Okay. So this region I am taking as 3. This is U3. 1 and 3. Now consider 1 and 3. So from this is 1 and 2. From 1 and 2 you are saying this thing. Now from 1 and 3, just tell me what is dt by dt dx. Are you? So what it will be? Minus minus 10. So what you see, this gradient in both cases will be same, right? Why it is so? This is so because if the width of the wall is decreasing, that means this is decreasing. The total width is from initially it is 4 and after that it becomes 2. Though the mm, thickness or width decreases, but the temperature drop will also decrease now. So say that if you are talking about this length from 0 to 4, the number of molecules in this system are more, right? But from 0 to 2, the number of molecules in the system are less. So that's why the temperature drop in this short distance will be less, but the temperature drop in this quite larger length is more. So cumulatively what we will get, that del T by del X is constant. So that's why the correct answer is option C. Is it clear? Hmm. So first tell me whether this example is clear or not, and this after that. Okay, up to this clear. So see, I am talking about from 1 to 3. Just look into 1 to 3 region. Okay. So in this 1 to 3 region, the number of molecules is, say there are 100 molecules. I am talking about these molecular levels. So in this molecular level, so all these 100 molecules will taking part in the heat transfer. So though and in from 1 to 3 100 molecule, but from 1 to 2 the number of molecules will be less, right? Because this is a rod na, say rod or anything. Uh, as the thickness is, you just assume one thing. I'm just giving you an example. A plate. This is a plate, solid plate. So if you just tell me one thing, if the temperature here is 100 degree, right? So at this temperature, say the temperature at this point, if I talk about 60, so at the middle point, middle or anything in between, what should be the temperature according to you? Whether it should be 60, it can be in between 100 to 60 something. So you just say 80, okay. So now you tell up to this length, say this length is your 4 meter, in this 4 millimeter. In this 4 millimeter, what is the temperature drop? In this 4 meter, what is the temperature change? Initially it was 60, initially it was 100 and after that it is getting converted into 60. That means the temperature drop means change in temperature. How much change in temperature? 40. So that means dt here is 40. dt means change in temperature or temperature drop, or dx means change in length. What is the change in length? 4 minutes. So that's why dt dx clearly indicate temperature gradient. So this term is known as temperature gradient. So what is the temperature gradient? This is 10, right? 40 by 4. Eh. So now in the middle line, you say that the temperature will most probably be 80. So what is the length of this line from this end? It is almost 2 mm, maybe. Yes or no? I am taking a middle line. So if the total length is 4 mm, so up to the middle it is how much? 2 mm. You got it or no? Just take. uh, hmm. Okay. So what is dt here in this case? Just tell me dt. In this case for 2 mm. That means 20, right? So and what is dx? 2. So you see, if the length is decreasing or the thickness is decreasing, the temperature drop is also here. Dx is 4, drop is more. Here length decreases, temperature drop decreases. Right or wrong? These two cases. This is one case. This is another case. You got it? Total thickness is 4 mm. For 4 mm, the temperature drop is 40, but for 2 mm, the temperature drop is 20. So so that means if the thickness or the length increases, the drop will temperature drop will increase, right? Yes or no? Got it. Okay, so I am just now using your mathematical concept. I am explaining this thing in another way. So I think if you will find this way also interesting. So qx is minus ka del t by del x. You know derivative? Hmm? Uh, so in derivative you have studied if something dx is 0 or constant. Dx is 0 means x is derivative of something is 0, dy dx. Uh, that means y is constant, right? You remember this thing. Why I am saying this thing? Either what is say for a given amount of heat flux, right? That heat transfer. That means here it is given qx is constant, right? For a given amount, that means the amount is known. So if it is a constant value, qx, yes or no? Do not got it. I am saying that for a given amount of heat transfer, for a given amount means the amount you know. amount is given, though the physical value is not given, but say given means it is constant. Anywhere if it is, if you observe that something is such types of statement is there, the given amount of x or given amount of y, that means y or x is constant. Similarly, given amount of heat transfer means here qx is constant. Next, it is written that the thermal conductivity is constant. That means K is constant. Area, one dimensional heat conduction through a plane wall. So the wall is plane. That means the area will not change. So constant it is also. So this one is constant, this one is constant, this one is constant. All of these three are constant. So what I can write? dt by dx is constant, right? And so area is constant through a plane wall. It is given a plane wall. So it is not given a variable plane wall nahi there. Plane walls mean these types of wall. So this is a wall na. So you talk about our room wall. In the room wall, if you take any section, its area is constant or no? Say this area, if this is A. So if you draw this here in the between, so what will be the area? Okay. So I am talking about this block. This is, say this is an wall. Okay. Wall or block. So if its length is, if it is B, W and it is L. So what is this area? W into B, right? This area is W into B. Yeah. So and what is the area in this region? It is also W into B, right? Just for example, you have any say you have a CPU or a book. Consider your textbook. So your textbook in the front side, whatever be the area and what is in the back side, the area would be same. And if you talk about a middle page, its area will be same, right? Surface area, I am talking about this thing. So that's why here it is nothing is mentioned, that is a plain wall. So we have kept the area constant. So as all the three things are constant, so del T by del X is constant. So I can write del T is constant, I can write it as C dx. I can write constant means C. I represent the constant as C. Is it clear? No, no, any cross section means if you cut this section anywhere. So in the book, say consider your book. If you cut your book from the middle, so that whatever be the area of the page, will it be different from the first page? I am so that is the thing. In the block, if you cut the block in the middle or it any distance, any thickness, it area will remain same. Cross section area will remain same. So that's why I'm saying. So now you understand dt equal to c into df. Is it clear? So if you integrate it, what you will get? T is Cx, right? Right now. So that means if the width of the wall is decreasing, temperature will decrease. That's why dt dx is constant. So the correct answer is option C. So you can also think of that way. Okay. Huh. Yes, yes. If you cut the book from the middle also, say if a book, in the book there are 100 page. So if you split or tear the book at the page 40, so whatever be the area of the top page and the top page of the split portion, that will be same, right now. Say you another example I am talking about, for a square you have seen bread. In the morning you take butter bread, huh? Hello. Huh. So I am saying that in the breakfast, would you take bread with butter? Bread, have you seen? Yeah. So in the bread, there are a lot of pieces there. 10 to 12 pieces are there. So you, if you take any piece in the middle or in the side, you will see that almost the area or area of the top surface is same for each and everyone. So I am talking about this thing. Huh. Yes, 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 yes. Okay, okay. So I'm moving to the next one. Okay. I I think if you understand this concept, a similar question is there for you. I hope that you will be able to. Now say, in the previous question it was talking about the temperature gradient. Now in this question it was talking about the temperature drop. So just tell what will be the answer. I think I have Sritesh has answered option B. So please try to answer. Hmm? Has it is a similar question like that one. In the previous question, it is saying if the width of the wall is lower, what happens to the temperature gradient? So in the previous question, it was asked about what happened to del T by del X. It was asked in the previous question. Now in this question, it is asked what happened to del T. Yes, good. It will be lower. Fundamental concept is clear now. Very good. So both Sitesh and Aya, both of you are correct. Now I am moving to the next question. So it's a simple question. So the heat flux is what? So either it's a scalar, it's a vector, it's a second order tensor or a third order tensor. Do you know heat flux? Okay, I'm giving you 1 minute time to answer this one. Yeah, yes, it, very good. It's the same concept. Heat flux means, so heat flux I represented Qx. Heat flux is Qx by area. Okay, so why I am saying this thing? Say this is a cylinder. Okay, this is a cylinder. If it is the area of this section, if it is Ax, area of that section is also Ax, right? And if you take a middle section also, its area will be Ax. Up to this it is clear. But if I take these types of cone type arrangement, if this one is area A1 and this one is area A, say A3, okay, so A1 is definitely greater than A3 here, right? This area, and in the middle the area A2 will be there, so I can write A1 is greater than A2 greater than A3. So in such types of body the area is decreasing, but here in this cylinder, in the top cylinder, the area is same everywhere. If it is A1, if it is A2, if it is A3, all of them are equal. Okay, so if here the heat is flowing Q through this region Qx, so the heat flux is Qx by Ax here. Here the heat flux is Q1 is Qx by Ax. Is it correct? Sritesh and Arya, is it correct? It is like magnetic flux, magnetic lines. So this magnetic, whatever value of this magnetic line divided by area, number of magnetic lines. So similarly here, if Qx heat you are supplying, so what is Q1? Q1 is Qx by A1, right? And Q2 is Qx by A2, and Q3 is Qx by A3. But here if you find Q2 or Q3, all of them will be same. Yes or no? At any section, cross section, if you find the heat flux, what is heat flux? Heat flux basically is the heat per unit area perpendicular to the direction in which the heat is supplied. You got it? Just let me know. First try to understand and let me know. No, I am talking about this area. This area is always should be perpendicular to Qx. That is the definition. So that is the definition of heat flux. That means heat is always flowing perpendicular to this area. So for this heat flux, you have to take perpendicular area only. Got it? So see, the heat is flowing in a certain direction. As it has direction, as it has a magnitude, so it is a vector. Clear? Okay, so I am moving to the next one. It says similar types of question. So what is given? Uh, Thickness is given, thermal conductivity is given, surface area is given, inner and outer temperature of the wall are given, the rate of heat transfer will be. That means you have to use the Fourier equation. So these types of block is there. See. So a wall of thickness 2 mm, that means it is given 2 meter. Thermal conductivity K is given 0.9. What is 2 basically? It is your dx is given 2 meter, right? And area is given 5 meter square, right? Inner and outer temperature of the wall. So if it is the inner temperature, it is given 1000, and it is, if it is the outer temperature, it is given 500 degrees centigrade. So you have to ask the rate of heat transfer. Rate of heat transfer means Q. So what you know? Qx is minus Ka. So minus is not required because we have to find out the magnitude also. Achha, minus you can put, not an issue. Right, that is the formula. Any confusion? Option B, very good. So here you know K is 5, area is, sorry, K is 0.9 into 5, or temperature difference is 500 minus 1000 by 2. Accordingly, you will get 1125 watt. Okay. So it's good that you understand this concept. So similar, so option B is the correct answer. So similar type of question is given. So try to solve this one. So I am giving just 1 minute, or it will be a homework for you. Just the difference is that here you are asked to find the thickness. Del X you need to find. You got the answer? So please use mic and say. It's a similar question. So where Say here heat flux is given. The difference is that, say, in the previous one you know minus Ka del T by del X. But as in this question, the heat flux is given. Heat flux means Qx is this one by A. That means if I take this A here divided by A, so what I will get? Qx is minus K del T by del X. So Qx is given 5000 and K is due to temperature difference is given as 300 minus 900 divided by del X. So you will get del X is 0.25 meter. So the correct option is option C. Okay. Okay. IA is solving. Okay, not an issue area. So any more question? Hmm. So and now I am just giving a little hint about this convection concept. Okay. Just a minute. Let me check on. Okay, okay, it is working. So this convection. So this convection concept. So what is convection? Convection basically is a summation of this conduction phenomena along with this fluid motion. Okay. So this is a combination of both two. So convection happens when the heat is transferred between a surface and a moving fluid. So it is because heat transfer between a surface and a moving fluid. Okay. So what happens if it is a surface? Say this surface, this is a surface, any surface, above which there is some liquid. Liquid is flowing over this surface. So what will happen? Initially, if you are supplying heat here, so through conduction first, it will heat up to this region. Okay. So for the conduction, heat is transferring from the bottom to the top, and after that, the heat is transferred to the away from the surface, which is because of the fluid motion. As the fluid is moving, so the heat is taking away by this fluid motion. So that is known as convection. Okay. Ria, is it clear? Please let me know. Is it clear? Huh. So what I am saying, say this is a block. If you are supplying heat from the bottom, what will happen? First the bottom surface will heat up, right? And after a few certain time, what will happen? The heat is transferred to the top surface, right? So this top surface will get heated up. Why? This is because of conduction. So as the top surface is getting heated up, say air is flowing over the surface. So if air is flowing over the surface, what will happen? The heat from the top surface is taken away by this air. So say if you take a cup of tea, and generally it is hot, right? And what you do, you just blow air over this cup of tea, so that is air is flowing over the surface, and because of this air the tea is getting cold, right? Because the tea is the air is taking up the heat from the surface. Now is it clear? So the heat from the top surface is taken away by the moving fluid. So always remember the convection is a phenomena or a moving fluid because of this moving fluid, but conduction is because of temperature difference. Conduction is because of temperature difference, whereas convection is because of a moving fluid. And important things in if you search in the Google, you will find three basic primary mode of heat transfer. That is convection, conduction, and uh, radiation. But in real life, there are two primary mode of heat transfer. This is conduction and radiation. But convection is not a direct is not a primary mode of heat transfer. You can't as you will fully cover this course, you will get to know that this convection is basically a mixture of conduction, but the here the conduction is affected by fluid motion. So the convection is a type of conduction where it is affected by the fluid motion. So as in the conduction you have studied about this what law you have studied about this Fourier's law. So here there is Newton's law of cooling. Okay. Yeah, there is Newton law of cooling. What it is say? It says that the heat transfer from the top surface by the moving air, it should be equal to HA T surface minus T infinity. What is H? H is the heat transfer coefficient. Like in the conduction equation, there is K. You remember? So similarly here H is the heat transfer coefficient. Ts is the surface temperature. T infinity is the fluid temperature. Okay. A is the area of the surface, exposed surface. That means this surface area here is the area of this surface. The surface of the block, this is known as area. And T infinity is the fluid temperature, Ts is the surface temperature, H is the heat transfer coefficient. Okay. So see, this is from the Newton law of cooling, but from the conduction you have minus Ka del T by del X, right? So basically here K is there and here H is there. What is the significance of these two terms? So K basically represent how easily heat moves inside a material. Remember this thing, how easily heat moves inside a material. Okay. And H means how efficiently or how easily fluid removes heat. Okay. H basically represent how the fluid is removing the heat from this top surface. This top surface, from this top surface, how it is, okay, So in this top surface, how easily the heat is transferring, so that thing has been pointed out by this H. Whereas in the conduction equation, the K basically represent how easily the heat moves inside a material. That means from here to here, how the heat is transferred from the bottom of the surface. Any confusion? From here to here, how easily the heat is moving, that has been portrayed by this K. Any confusion? Please let me know. Okay, so I am moving to one of the question. So say this is a question. So where it says that the back surface of a plate is heated at a rate, the rate is given, right? At a rate of this, what is it? 20 watt per meter square. So heat flux is given the back surface of a plate. That means, so the plate that I have shown in the earlier slide is talking about this plate. Okay, so it is given here. What is given? The Qx is given, or Q conduction. I can write Q conduction is given. It is given as 120 watt per meter square. It is given, and the front surface is cooled by air surface. When this surface is cooled by air flow. What is the temperature of the air given? It is given at 30 degree. T infinity is given as 30 degree, and the heat transfer coefficient between the air at the plate. So H is given as 60 watt per meter square degree centigrade. Okay. So considering steady state, what is the temperature in the front? So you have to find the temperature of this region. So see, if it is given, you can easily find this thing. So in this region, what is if I take this point, I know because of convection, the formula is H Ts minus T infinity. Though you say that the formula is capital Q equal to HA, but I have written it as small h. So that's why a small q. That means capital Q by A. Is it clear, Arya? Hmm. So for this reason, for the top, this is for what? Front surface, yeah, or top surface or front surface? Front surface. I have written, so H is given as 60, Ts I don't know, T infinity is 30. So that is given. So here, as this heat, this conduction heat, this heat is transferring to here, right? So that means whatever the conduction is happening, that should be equal to convection. Up to this it is clear. Is it clear? Hmm. So what is the conduction? It value is given 100 to NT, and Q convection, this is 60 Ts minus 30. If you calculate, you will get Ts equal to 32. Is it clear? It is an important question. Such types of question we will ask. It's a very important question. Please solve this question. And remember one thing, I will share these types of question and this PPT with you. And this video will be uploaded in a YouTube link, and the link will be shared to you by this NPTEL. So after 2 to 3 days, they will ask for feedback about these classes. Along with this, they will provide you with this PPT and this video lecture link. Okay. So next, and this is a, so this is the next question. Next 2 to 3 questions are there. It will take 5 more minutes, and we will wind up this session. So the thermal diffusivity of a substance physically implies. So what is thermal diffusivity? So I think you haven't learned this thing. Thermal diffusivity means there is a formula. So before coming into this formula, so the thermal diffusivity, if you observe, it consists of two terms. So one is K, one is rho Cp. Okay. Have you learned this thing in your class? In the first year, that means you are in second semester, right? Yeah. Okay. So basically, what is thermal diffusivity? Thermal diffusivity means how fast a material or how quickly heat spread through a material when its temperature changes. So I can write, represent how fast a material reacts to a change in temperature. That means it's a parameter. Like you see, certain people are there who have, if you I am talking about this a metal rod. If you heat a metal rod at one end, and if you are touching at the other hand, you will feel the heat very quickly, right? But at the same time, another rod, if it is made of an insulator, if you heat it and you are catching the other end, you will not feel the heat. So that means material is quite important. So each and every material have a certain thermal diffusivity. It basically represent how fast a material react to a change in the temperature. Okay. So here this is the formula. Please remember this formula. In this formula you will see two things. So the top portion is K. What is K? K is thermal conductivity. So what thermal conductivity represent? Ability to conduct heat, right? And what rho Cp indicates? Cp is specific heat. So what Cp indicate? What is specific heat? You know, abilities to store energy. Okay, that means if you say this thing, it basically represent the ability of a substance to conduct heat with respect to the ability to store energy or thermal energy. That means how fast it conduct heat and how fast it store energy. Both the thing is represented by this thermal diffusivity. So they see The first option is partially correct. The second option is also correct, but the third option is not correct because it will not generate heat. It only store heat, store energy. And option D is none of the above. It is correct because there is no such option where it is mentioning option A and B. So the correct option is both A and B. Is it clear? Huh? You can? Huh? Yes, D is right. Because if there is multiple option, then A and B are correct. But it's a single option, so that's why D we have to choose D. Okay. And in the if in the exam it is not mentioned whether choose the correct answer only even single option or multiple option nothing is mentioned. In that case you can choose A and B. But generally it is not happening. Generally say single take the correct answer only. That means only one answer. So in that case you have to take D. So last two question I am moving. Just tell me this thing. I think it's a very simple question, and Arya and Sitesh will definitely answer this one. Option D. This one or this one. All of them are correct, na? Okay. Yes. Where is this? Yes, both of you are correct. So last question for today's session. So just it's the same question again. I'm repeating. So now tell. Though it's a repeating question, I think you will be easily able to answer. Which one will be the answer? Uh, B. No, actually, so there is a little bit confusion. So basically, just see what I have said. Just remember the formula. So that will K by rho Cp. That is the formula. So this rho Cpt is the thermal energy. So the thermal energy is in the denominator, right? Thermal energy, and this one is your thermal conductivity. That means to conduct. Conduct means to conduct energy. Okay. So basically, the conduct means your transport. Conduct or transport is same thing. So the correct option is the ability of the material to conduct energy or to transport energy, whichever you say relative to its ability to store energy. So A is the correct answer. So is it clear? So Arya, I hope that you understand your mistake. So it's a silly mistake. You know the concept, but the thing is that whichever is in the numerator and denominator, you get confused. So it is not you. Even many of us also make the same mistake. So please go through this concept precisely. Try to understand each and every question and every concept, and if you are not aware of any concept, please let me know in the next class. So we will have another session on next Saturday at the same time from 3 to 5. Okay, any doubt up to this? So your mistake is basically you are saying option B. Option B is basically the ability of the material to store thermal energy. So thermal energy means rho Cp. Okay. To its ability to transport energy. Transport energy means conduct. K. Transport means conduct. So based on your response, then alpha would be rho Cp by K. You got it? So you just uh, do it inversely. If I take your answer, it would be rho Cp by K. So which is wrong? It is a ratio na. In the ratio, the numerator should be K. So that means ability of the material to transport energy, it should come first. Is it clear? If you measure it, rate, no. See, it is based on the definition, nothing else. Just see what I am saying. This formula you just see. So your concept is correct. Say if I say alpha is 2 is to 3. So you have to say the 2 first, not 3 is to 2. Both are different na. 2 is to 3 and 3 is to 2 both are different. So that is the mistake you have made. In your case, the ability of the material to store thermal energy. This is rho Cp, and its ability to store energy. This is K. So based on your formula, it is rho Cp by K, which is wrong. You got it? Huh. So any other confusion? So if you have doubts here, better I am just giving you a mail ID. So you mail to me the your doubt. I will answer it through your mail. Is it okay? So I am just giving you this mail ID. Please note down this mail ID. Is it visible? Also, you can do one thing. You can mail me your doubts. I will answer it here. And also, the next thing you can do is that you can put it in your discussion forum. So that thing also you can do. So whatever you feel, you can answer. And in the also another thing you can do, you can join the next class a little bit early. Then also it can be. So have you note down this mail ID? 0 A22ME09005. Okay. So hope, huh? What? Yes, PPT I will share with the NPTEL, and they will provide you with the link within 2 days. Every live session and every PPT they will share with you. And even you will got this live session. If you forgot anything, you can go through this live session. It will be uploaded in YouTube, and the link will be shared with you. Okay. This is for the once the link is shared with you from the first class, and after that you can easily go through this link and you will get all other information. Okay, so I hope I'm able to clear your concept and having, so hope we will meet on the next Saturday. Thank you and have a good day. Bye.